Today we're going to continue our lessons on dilations, but today the center of dilation is not at the origin. Today's date is May 28th. Your note packet should have 3 pages, and you'll also want to grab a ruler or straight edge so that we can make the coordinate plane graphing look good. Yesterday, we dilated our figures through the origin, but the center of dilation does not have to be at the origin. So we do want to pay attention to the directions when it tells us where the center of dilation is. So in my picture, point B is going to be my center of dilation. And I know that right now because they told me. But yesterday we learned that the pre-image E and the image point E prime, if you were to draw a line connecting them, we would eventually locate our center of dilation. One set of points won't do it. We would also want to connect, let's say, C and C prime, but those two lines will converge, and where they meet, we'll locate that center. So just what I said. If you were to find the center of dilation, it can be found by connecting the points of the pre-image and the image, but you'll need at least 2 sets to confirm its location. One set won't do it. And I think we saw this diagram yesterday. So you'll notice they connected all the vertices on the triangles for the blue and the red. And we're not sure if it got bigger or smaller, but it doesn't matter because they all converge to that dot, and that would be my center. When you dilate through a point that is not at the origin, you have to tell the reader where it is. So in this first example, we know we're dilating, capital D, but the center of dilation would be labeled C. And then the scale factor is 2, so I need to make it twice as big. If your center of dilation doesn't have a letter to designate it, you're going to list it in the second example as an ordered pair. So my center of dilation is at 3, 1. And then in this one, the scale factor is 1/2. So I'm going to make the figure half the size it was. For this example, we're going to draw the dilation of triangle JKL. C is my center of dilation, and we're going to make it twice as big. Now, mine's not going to look as good as yours because you'll have a ruler. But what you want to do is line up C, the center, and K with your ruler, and you want to make a straight line. You can actually measure your distance, and you don't have to be extremely particular, but measure the distance from C to K. And then what you want to do is measure that distance again from K. And I'm just going to approximate it's here. This would be K prime. I'm also going to have you take your ruler and line up C and L. We're going to measure the distance between C and L. And again, you don't have to be super particular, but we're going to increase that. So from L, we'll find L prime. And then we're going to do the same with J. So with your ruler from C through point J, we'll measure the distance. And then we'll move it twice as far away. And I'm just approximating because I can't truly measure. This is J prime. Now that you've located all the prime locations, we're going to take our straight edge and we're going to connect L prime, K prime, and J prime. And what you should see is the image that you've created should be twice as far away from C as well as twice the size. Let's try this again. We're going to dilate triangle JKL. The center of dilation is again at C. This time the scale factor is -1/2. All right, this is a little bit different. So let's start with our ruler. We're going to line up C and K, but instead of going past K in this direction, we're actually going to go past C in the other direction. The negative scale factor will move the triangle from the left side of C to the right side. So what I'm going to do is take my ruler and I'm going to measure this distance from K to C. And then instead of going all that distance, I'm going to go half the distance on the other side of C. So if K to C was 2 inches, I'm going to go only 1 inch, and this is K prime. We're going to line up our ruler again between J and C, and we're going to keep going. Again, you're going to measure the distance between J and C. Then we're going to cut that distance in half, and we're going to place it on our line, I'm guessing, here, J prime. And our last point will be L. Make it pass through C and extend it. You can measure the distance between L and C, and then we only want to go half as far. We'll call this L prime. And then I'm going to take my ruler and I'm going to draw the new image. So J prime, K prime, and L prime. So my new triangle should be half the size it was, and the negative scale factor puts it on the opposite side of the center of dilation, and it's also facing the opposite direction. So hopefully you're going to get that and it'll be clear. Sometimes the scale factor is not provided. We don't really want to guess. We want to calculate its actual scale factor. So what we'll do is we'll set up a ratio, and it's going to compare the image and the pre-image. So we'll have K equals image length in the numerator, pre-image length in the denominator. So for this set of examples, we're going to determine whether the dilation is an enlargement, a reduction, or a congruence transformation. And then we have to come up with the scale factor. So in this first picture, we started with the blue quadrilateral and it turned into the green quadrilateral. So clearly we can see that that is an enlargement. So my dilation got bigger. And then we want to look at the scale factor. Remember, the numerator should be the image. So if I look at A prime, B prime, the length is 6 blocks. And the original image had length of AB as 3 blocks. So the scale factor will be set up as 6 over 3. So it reduces to 2 over 1. So my scale factor is 2. My image was twice the size of the pre-image. For the second example, the red and the blue do overlap. So what they've created is a congruence figure. It didn't get bigger, it didn't get smaller, it stayed the same. We can still set up the scale factor, but hopefully you remember this from yesterday. If I compare the image and the pre-image, since the lengths are the same, the scale factor is 1. So anytime you have a scale factor of 1, you have produced a congruent figure. All right, into the graphing. If you have to do this today, and you will, we're going to start with our 4 given vertices, W, X, Y, Z, and we're going to go ahead and graph those. I'm also going to graph the center of dilation of -5, 5. So there is my funky quadrilateral. This dark blue dot represents my center of dilation. In order to figure out where the new figure goes, we cannot use a multiplication rule because we moved away from the origin. But I do have to make my figure half the size. What I'm going to do is draw a line connecting the center of dilation to my first point, W. We're going to use the distance that it is from the center of dilation, and we're going to cut that distance in half. So from W to this point, I would have to rise 4 units. So I'm really going to only rise 2. And then to go all the way to the point, I would have to run 3 and then 5 more, 8. So I'm going to rise 2 and run 4. And right here is the location of W prime. So it's at -1, 3. So the image point should be on that straight line that we have drawn in. Let's do the same with X. I'm going to draw a line from the center of dilation through X, and I'm going to look at the path. So I would have to rise 1 and then 5 more. I'd have to rise 6 and then run 4 left. We're going to cut those distances in half. We're going to rise 3 and run 2. So right here is the location of X prime. We're at -3, 2. Let's add a line from the center to Y. Same thing here. I'd have to rise 4 and run 4. So let's rise 2 and run 2. This is my location of Y prime at -3, 3. And then our final line passing through Z, I would have to rise 2 and run 6. So we're going to rise 1 and run 3. And right here at -2, 4 is the location of Z prime. We don't want to forget to put our transformation rule. Notice I put down the center of dilation and I did make a mistake. That should be -5 there, 5, and it's a scale factor of 1/2. The last thing we have to do is graph the figure, and we'll use our ordered pairs. Take those lines out. So it's the same shape, but it's clearly a different size, and all my prime notations are present. We can see that the figure became half the size and it moved in half the distance to the center of dilation. In our next example, we have a triangle XYZ. The center of dilation is at 6, 3. The dilation is going to become twice the size, but because it's negative, it will move to the opposite side of the center of dilation and it's going to face the opposite direction. So I'm going to start by graphing triangle XYZ, and I did plot the center of dilation in this dark blue dot. We're going to use the same technique. So I've got my dilation rule all set up to do my mapping, but I am going to make a line from X through the center of dilation. We're going to count the pattern. So if I rise, it's 1, 2, 3, 4, and then over 2, 4, 6, 8. We're going to double that distance. So we're going to rise 4, run 8, but then we're going to do it again, rise 4 and run 8. So ultimately, when you do this, and it'll be easier for you to count, my location of X prime is at 22, 11. I did put a prime notation there. You can also put a dot there. Let's do this again now with Y. So I'm connecting Y through the center of dilation, but I'm extending it. The path from Y to the center is rise 2 and run 5. We're going to do that twice to move away, twice as far. So we're going to rise 4 and then run 10. So there's Y prime, and its location is at 16, 7. We're going to do this one more time for Z, so we're going to connect it with a line. The pattern is to rise 3, 6, and run 5. So we're going to rise 6 and run 5 twice to get twice as far away. And I'm going to mark Z prime. It's right on the top of my grid, and it's at 16, 15. I'm going to go ahead now and place dots there and then make my triangle. Again, it's the same shape, but it's twice as large. It's on the other side of the center of dilation, and it's facing the opposite direction. This is normal when you reflect with a negative scale factor. Tonight's homework is number 128. It's just a two-sided worksheet. Make sure that you graph and you list full mappings if that's required. If you have any questions going through this assignment, and I know this one will be a little more challenging, please make sure you ask me questions and get in touch with me. Have a great day.